Okay, we're almost done. Two more. A Boy Scout on top of a 1,700-foot tall mountain spots a campfire. If he measures the angle of depression at 35 degrees, how far is the campsite from the foot of the mountain? Okay, so this one's going to be tricky just because angle of depression tends to be the one that people get wrong. So I'm going to give context to the problem so that it helps me to kind of figure out what's going on. So here's my fancy mountain. Here is my Boy Scout. He's just chilling on top of the mountain. And he's going to see a campsite. So here's his tent. We got a burning fire. Not my best work, but it's going to work. Now it's a 1,700-foot tall mountain. So that's this vertical distance. Now, angle of depression. He only sees that campfire if he looks down. Otherwise, if he looks horizontally, he kind of sees nothing. So we need to say the angle of depression down to this campfire is going to be 35 degrees. And as I mentioned before, I always deal with the triangles that kind of sit on the ground, essentially. So I'm going to focus on that one here. So in this right triangle, I have a 1,700-foot vertical length. I don't really have anything else yet. I do need to note that I'm finding how far it is from the foot of the mountain. That's a fancy way of just saying the bottom of the mountain. So he's not Superman. He's not going to fly to his campsite. He'll have to climb down the mountain, and then from here he can walk to his campsite. That walking distance is what we're going to be finding. That actually might get put on another page, so I'm going to put it here. And currently, I can't solve this because I'm missing a side of a right triangle. Pythagorean theorem's not an option if I only know one side of that triangle. And I don't have any angles inside this picture, but I could. The angle of depression to look down to the campfire is the same as the angle of elevation to look up to the Boy Scout, which means the 35-degree angle can go here. It cannot and will not ever be here. From where it should be, from here, I can figure out that X is right next to my angle. 1,700 is across from my angle. And like I said earlier, we're going to get a lot of tangents. So I'm going to say tangent of my angle is equal to the ratio of the opposite leg over the adjacent leg. When we find sides, we solve by cross multiplying. And since x is not yet on its own, we will solve for it by dividing. So 1,700, as I draw my calculator, 1,700 divided by the tangent of 35. So 2427.85. So about 0.9-ish. And last problem. A soccer ball is placed 12 feet away from a goal post that measures 8 feet high. You kick the ball and it hits the crossbar at the top of the goal. So here's my soccer ball. I will not be capable of drawing that successfully. Sorry, soccer players. And it's kicked so it hits the goal post. So here's my fancy goal. Doesn't matter. This might be a good time to say, drawing abilities, remember, worthless. Don't mean anything. The important thing is to note, if my soccer ball's here and it's 12 feet away from my goal post, that's a horizontal distance we're being told. So this distance is 12 feet. The post is 8 feet high. So anytime you're told how high something is, it's a vertical distance. And it's kicked so that it hits the top. So when this ball is kicked, it goes straight to the top and hits it. We could find that distance, but it wants the angle of elevation up from the horizontal line. So they didn't just kick it and it rolled horizontally. They kicked it and it went up from the horizontal. That angle is the one that we will be finding. So from that angle, and noting that we have a right angle when we talk height, we can label our triangle. We have the hypotenuse, we have opposite, we have adjacent. And again, we're not using the hypotenuse. So I'm going to write tangent of my angle. My angle is just some unknown x is equal to the fraction of opposite over adjacent. Then, since I know I'm finding an angle, I'm going to do so by using inverse of tangent. So I'm doing tangent inverse to both sides of the equal sign, and that will be what I put in my calculator. Oops. I messed it up. Give me a second. Like I said in another video, I'm using a backwards calculator and I'm not used to those. 33.6-ish, so it's about 34-ish degrees. The main thing I honestly want to point out about these problems, you can't see that. Let me pick a different color. So here's my right triangle. I drew it kind of like it's sitting on the ground. Here's my angle of elevation in this problem. Yeah, I drew a lot of other crap in the picture, but here's the right triangle. Here's where I ended up drawing the angle of depression, because remember we said it's here, but it's also here. In this problem, we had a right triangle. I drew it that direction, and then I put my angle here. It's not a coincidence that every time I draw the same basic triangle, and then I put the angle in the same basic spot every single time. Triangle, the angle goes in the same spot. So I basically always draw the exact same triangle, either like this or like this, and then the angle goes here. Never ever in any of these did you see me put it at the top angle. Sometimes it started at the top outside the picture and then we just moved it down below, but it will never ever start at the top. So if you find yourself really struggling trying to draw these, just draw a triangle, either like, not like that, either draw a triangle like this or like the one right above it,